A warm welcome. This is Electric Energy Generation, Utilization and Conservation course with lecture 5.6 focusing on earthing. We are going to see about the earthing in the domestic field, the industrial sector as well as in the substation. See what is earthing. Actually, if a person touches an appliance where heavy current is passing through, then automatically his body will be in contact with the appliance and the heavy current will be flowing through his body towards the earth. Automatically, this will create a fatality to the particular person. In order to avoid it, all the appliances, electrical appliances, have to be potentially grounded. I mean, the earthing process is the main one, which is bonding a non-current bearing parts of an electrical device or the neutral summit for the electrical organization to the earth through the wires. And this will cause a minor resistance to and allow the flow of current directly towards the earth. So what and all the requirements of earthing? In this way, you can reduce the fatalities when a person is even unknowingly, if they touch a device or appliances, they will not get into any shock or nothing. And next, to warrant that all pieces of equipment in use by the occupant of a building or an earth potential. This is the first one. We have to safeguard them from the electric shocks through that when they directly touch the equipments. And then to protect the electrical apparatus, they may get damaged when heavy current is flowing through them. And to sustain the stable voltages in the three-phase circuit, because in three-phase circuit the stability, I mean the balancing of three phases is very essential. So that for that purpose proper earthing has to be done. And during the timing of lightnings, to protect the tall buildings by getting harmed, proper earthing is provided. While considering the types of earthing, we have two main earthing, namely system earthing and equipment earthing. So what is system earthing is nothing but the entire system will be in connection with the earthing, that is called system earthing. And equipment earthing is nothing but certain different types of equipments alone will be subjected to earthing process. For example, in system earthing, this is the type of earthing which is associated with the current carrying conductors. So it's quite relevant because there may be overflows of currents through the process of its transmission. They are used in stations, substations of electrical supply normally. The entire system will be under earthing process. While you are considering equipment earthing, this is a earthing for homes and other buildings. That is, we can safeguard the non-current carrying apparatus and the metallic conductors. It will not be earthed. You can just earth the necessary appliances which will be subjected to shock. We have to add water to the earth where we have given. I mean, where the earthing is made, adequate amount of water has to be appropriately provided, because we have filled the earthing system with the charcoal, then with certain cement concretes, and we have salts and certain materials which may help in avoiding the corrosion effect. So in order to prevent this and provide proper adequate watering has to be made through. Next type is the piping earthing. So for pipe earthing, it is very simple. You are just going to dig a hole in order to place the pipe. It is a cylindrical pipe, and that pipe structure, through the pipe structure, we have to pass the wire mesh. Through the wire mesh, the electricity can be passed over to the earth. Here, if you are digging long, I mean, when the length of the digging point is very long, then you can have a brake system like this. We can have a brake system. Why is it done is to improve the strength of the earthing. It is. Next is rod earthing. So in this method, the hammering of zinc and copper rods can be made. It is, I mean, they hammer the zinc or copper rods into the general mass of the earth. Not only one rod, successive rods are then screwed together. They'll be placed in the earth and then they'll be screwed. And it will be forming a chain-like structure, and this will try to lower the resistance of the surrounding soil. Thereby, when electricity high current is passing through the circuit, this low resistance will provide a way for it, and all the electricity will be drained out if it is a harmful one at that condition. The earth wire is tied and clamped near the summit. This is a very economical and quick procedure for earthing actually. The copper rods may be of 1 to 1.5 meters length and 12 to 20 diameter. Next one is the earthing through water pipe. Actually, this is a difficult one. Anyway, it was carried out in certain cases. What is the thing is, there may be hand pumps near the streets. So what we have to do is, the earth wire is tied and clamped to the GI pipe of the hand pump. The hand pump are used to extract the water from the bed actually. So there will be a ground level. The ground level till the water bed is reached, the ground well would have been digged up. So through that the earth wire will be tied and clamped. This pipe will be serving as an excellent electrode for carrying the excessive currents deep below the ground. But the thing is, there may be possible shocks for the users who handle that hand pumps. If unless and if suppose the earth wire touches the hand pump, then definitely shock will be occurred at that case. While considering next the methods of installation, we can see the different processes like piling, backfilling, inserting electrodes, earth pit, etc. are being made. So we'll study one by one. What is piling? Installation process will start with piling. So pile diameter should be twice the electrode diameter. Similarly, earth pit electrodes can be made by manual as well as boring process. That depends upon our economic condition and depending upon the number of earth pits to be done. If it is more number of earth pits, then going on with the boring process is a better one. Next, process is the backfilling. Commonly, this practice is used to form alternative layers of backfill compound, and soil is treated with water for moisture. Generally, 20 kg bag of LT earthing and 40 kg bag is used for HT earthing, depending upon the soil conditions. What is next is inserting of electrodes. The earthing electrodes is inserted in soil, and the specification of that electrode depends upon the type of the soil, how much load it is going to handle, and what are the other related parameters, etc. That is, what are the power quality issues that may occur, which has to be handled, etc. etc. And next is the earth pit. The earth pit is after the successful installation of earthing the electrode, the earth pit chamber is to be designed below or above the ground level as per the requirement. A cast iron cover is being made of different sizes. The earth pit design detail, the earth pit size is 1000 cross 1000 cross 1800 mm depth, with the plate size from 500 cross 500 cross 8 mm thick. While considering domestic earthing, so domestic earthing is nothing but this is the earthing which we normally use in our households or in commercial fields. The following is the method of implementation of the earthing in domestic sector. Low earth resistance is required to give effective earthing to the electrical fittings. Dry earth has more resistance, whereas moist earth has less resistance. The location of earthing point should be minimum 3 feet away from the residential unit. The location of the earth pit should be such that where the soil has reasonable chances of having moisture. If possible, the earth place or the pipe should be located near water tap or water drain or rainwater pipe. Electric earthing may be either pipe or plate earthing, and then normally GI pipe of size 2.5-inch diameter or plate 600 mm cross 600 mm cross 3.18 mm is used. But if the soil is a corrosive one, then copper pipe or plate should be used rather than galvanized iron. Usage of double galvanized iron striper with the size 25 mm cross 2.5 mm to connect the galvanized iron plate to system earthing. We can use that setup. And by considering the SWG galvanized iron wire, it can be used for internal connections. We can use backfilling component like bentonite for low soil resistance, and the position of the earth plate or pipe when fixed should be clear from all building foundations. Inside the building, in addition to all electrical appliances, all switch boxes, meter boxes, etc. should also be earthed. Here we don't have any earthing. Here additional earthing point will be provided. Here we don't, I mean in case of TNC system we'll have additional here it is not necessary, and the system will also be of compact size. While considering IT system, so individually for three phase and the single phase, separately we have to provide the earthing case. While considering the substation earthing, adequately all the substation equipments have to be under earth system. I mean it has to be provided with earthing. Provision of adequate grounding in a substation will be helping the substations to provide safety or to ensure safety for operating personnel as well as the electrical devices. The voltages will not rise above the threshold levels, and thus the earth connection is rugged to dissipate the fault to the earth. The importance of an effective, durable and dependable earth for ensuring the safety from electrical hazards, this does not require to be elaborated upon more. This is very simple. Surely it has to be flexible, it has to be durable, it should be completely dependable. I mean, it should be completely, totally reliable one. So by earthing, connecting the electrical equipment to the general mass of the earth, this will offer a very low resistance. Now let us see what and all the earth resistance which are considered in various other substations, how it should be. For generating substation, it should be less than 0.5 ohms. For large substation, less than 1 ohm. Small substation, less than 2 ohms. From earth electrode to internal assembly, it is 2 ohm, less than 2 ohms. For neutral bushing, it is less than 2 ohms. For service connection, it is less than 4 ohms. For LT lightning arrestor, it is less than 4 ohms. For low tension pole, it is less than 5 ohms. For high tension lightning arrestor, it is less than 8 ohms. And for high tension pole it is less than 10 ohms, and for towers it is less than 25 ohms. So these are the substation earth resistance values, and how the substation earthing can be made effective, and how is it necessary in order to ensure proper flexibility of usage of all the electrical appliances in homes by the consumers. Thank you. There are also certain instructions about the earthing in substations. On pole of high tension line, the fittings of all metal parts should be fixed by using the galvanized wire of 8 SWG. And for the pole of low tension line, the fittings of all metal parts and stay should be connected to the neutral, and this neutral is to be solidly earthed with multiple earthing. The earth wire of the lightning arrestor should not connect to any pole. It has to pass from the Alcathon pipe and tightly connected to earth electrode. So what and all the type of earthing that is to be used is CI pipe type should be used. The size of the electrode is 120 mm, 3000 mm length, and I mean 120 mm diameter and 3000 mm length. Size of the galvanized iron stripe is 25 mm cross 2.5 mm, and the number of earthing pipes which are used is calculated using the formula total fault current divided by the maximum current dissipated by one earthing per pipe or electrode. This is how the substation earthing is being designed and executed. Thank you.